right, in a previous video, I went through the jets that I had in my DCOE 45 carburetor. And to verify that we had the proper jets for that particular engine, I went to this website here. It has a really nice calculator, carbparts.edu/calc. I'll put a link in the description so you can get there quickly. In that prior video, we ran through the calculator. The MG has an 1800cc engine, 4 cylinders, max RPM of 6,000, only one carburetor. One of the commenters had asked, what did it look like for power? And power recommends a choke of 40 and quite a few different settings. For instance, the idle jet goes to 55 F9, which means it wants more air in the idle. And so there was a lot of different settings here. Now, the thing about the way that I plan on driving this car is I'm not going to race it. I just want to be able to drive it around, have a dependable vehicle, but it is a low weight to power ratio type of configuration with the MGB. So I think that the real thrill of driving that will be, from start to stop, going from city driving or even just zooting around in some farm roads. You're not going to be going top speed, but you're going to want to be able to accelerate quickly. So your low to mid range is what I'm favoring. So I decided that we're going to calculate this for flexibility, one carburetor, and I want to favor the lower end. Now, in an early video a couple of months back, you can look back in my history. You can see that I replaced the single row timing chain with a dual row timing chain with a dual sprocket. The dual sprocket timing chain also pushes the power curve to the lower to middle range of the vehicle, whereas the single chain sprocket was mid to high end. And so I'm already favoring that low end. So let's go ahead and see what it says here about the size of this choke. In the site here, it recommends the size of the choke affects the velocity. Small diameter improves acceleration and torque at lower speeds, while lowers the maximum power at high speeds. Large diameter allows high speed at maximum power, but the engine is sharper, I think, probably, and may lack of power at the low speed. And you can change the diameter at this field to recalculate your jets. And so that's what I did. The current choke that we have, I just wanted to see what this would do. And it says if I put a 34 in there we go. This is the choke that I have, is a 34. My main jet goes to a 135, and I currently have a 140 on my main jet. So I'm good with that. That's like one tick away. I don't think I need to replace the main jets. And that still has us at a idle jet of a 55 F8, which is what I've ordered. So what we're going to do today is I've ordered new aux venturis. I now currently have a brand new set of 5.5s, and I've also ordered new idle jets, so the car will idle at a reasonable RPM. And so that's what we're going to do today. We're going to go ahead and replace the idle jet and the aux venturi on the carburetor, leaving the choke at a 34, and assuming the main jet that we currently have is going to be fine. I've cleaned everything with a carburetor cleaning bath, and so all of the orifices and jets are clear, and there's no more clogs that I had from the bad fuel. So let's go ahead and get started. I'm going to take you on over to the table, and I'll show you what the aux venturis look like and how they differ from the old ones. All right, so here you can see we have our old choke. This is not what you would think is a choke, but this is basically the main venturi on the Weber. It goes in like this, goes in this direction. The airflow is this direction right here. And what that does is it creates low pressure right here over this hole. There's a jet that drops down in here, and that's the intermediate jet. It comes right out of this hole right here. The idle jet is right about here in the hole. It's past that, but you'll see when we get it all back together. But here you can see this is a 34, and on that calculator, the 35 was what was recommended for the 140, which is what we have here. And I'm thinking that the 140 is going to be fine with the 34 because it was just kind of floating in there, kind of in between. The old auxiliary Venturis were 3.5, and the new ones that we purchased, you can see are, these are 5s. It called for a 5.5, but I think this is the closest I could find online. So when you're looking at these auxiliaries, you really can't see much that's different. I measured all the orifices and everything here. Everything seems the same. The one thing that is different is the size of this hole right here. You can see this hole right here is much bigger than this right here. And that allows for more air and fuel to pass through and be distributed by that little jet right down inside there. I don't know if you can see that. See how much bigger that one is than this one? You can see up in there. But that's what the difference is between these two. Now, when I got these, one of the things I recognized was that there's a lot of, I don't know if you can see, like these little molding scraps where, I'm sure this is a very complicated part. It's very difficult to mold these. So there's a lot of seams in here. And I mean a lot. These are airfoils, and so you got to think, you don't want to have, at least on the leading edge, you don't want to have a whole big old seam right there. On the old ones, you can see they had the same thing. There's like a bump. You can see the bump right here. That's the seam from manufacturing. So I think it's just a thing. It's not like these are poorly made. It's just how they come out. But what I decided to do is to take a small file. This is the one that I've already processed. And just kind of minimize that. I went through and knocked off anything so it feels smooth, at least for the way that the air flows that direction. I just want to make sure there's nothing that's going to cause any kind of unexpected vortices or anything that's going to create a break in the airflow. And this is a little file that I used. This is actually a file used for sharpening chainsaws. So, I mean, you don't have to go out and buy something. If you have something, then you can do it. I don't know if I would go with sandpaper because, you don't want to introduce any abrasives. Obviously, when you get it all filed off, you want to clean it. But I'm going to go ahead and finish filing. I'm going to file this one down next because there's all along the bottom down here, those are really big, and they're definitely going to cause a little bit of a bump in the airflow. So I'm going to go ahead and file these up, and then we'll move into the engine bay and install these jets. Now these jets, these are the old jets right here. They have a marking on them, says 45F8. The jets, they come right out of this little emulsifier tube. It allows air to go in, air and fuel to go in through these little holes right here. The F8 is this hole right here where the air comes in, the fuel comes in from these holes. But this F8 right here it's not a sequential number like 1, 2, 3, 4, 5, 6, 7, 8. It's an iteration number, so you can't expect one to be bigger than the other. The new jets, you can see, here's the new jet. If you were to hold this up together, I don't know if I can get enough of glare in there so you could see, but you really can't with naked eye tell the difference between 0.5 of a millimeter or 0.4 of a millimeter. But that's where the primary number is, 50 or 45. These are 50s. And if you can see, The F9, the air hole, you can see that with the naked eye, that air hole is a little bit bigger than this air hole right here. So we're going to get a little different flow characteristics from the idle circuit when we install these, and hopefully that'll make it so we can idle a little better at a reasonable RPM. These things, they just slide right onto these emulsifiers. You just put them right in the hole right there. This one's a little tight. But you just slide them right in there, and you go home and you just screw this baby in and off you go. So I'm going to go ahead and put these things in the carb, and we'll see you in the engine bay. All right, so first thing we're going to do is we're going to install these jets. We'll get started with the mains. They go right in the front. All right. And we'll drop these idlers in here. These just kind of screw in place. Don't need to put a whole lot of torque on them. All right. The last thing is we need to put these pump jets on. Now you'll notice that they look very similar when you look at them. You just got to orient them the right direction. The aluminum washer goes down, and they go right into these little holes right here. He said confidently. Actually, these are going to these actually interact with this right here. They'll kind of go in like right there. So if your choke is out of position, you won't be able to get it into there. So we're just going to make sure that you got everything all lined up the way it's supposed to be. There we go. And they have a little cap on them. Make sure that the little rubber bushing, this little rubber O-ring, make sure that's in good shape before you put that on. Okay. Now the next part's going to get a little tricky. So these chokes, as I was saying, they have a slot right here, and that slot kind of has to go past that pump jet, right? So when you set them in there, oh, I forgot one thing. Let me pull one of those pump jets out, and I'll show you what I forgot. All right, so when you're looking at these pump jets, do you see how there's a notch on one side and then there's no notch elsewhere? That means that they only go in one direction. And the reason why they only go in one direction is that the hole, this little hole right here, needs to be pointing so that when it gets pumped, when you step on the gas and it shoots fuel, raw fuel down this little hole, it needs to shoot it in the right direction. You don't want it to shoot in the other direction. I don't think you can make a mistake, but I just want to point out that there's a flat spot here, and that makes sure that this jet is pointing in the right direction. All right, so I covered that. Okay. All right. All right, so knowing that that this slot is going to match up, you need to make sure that when you put these chokes back in, that you put them in with the slot oriented this direction. But that's it's either going to go in or it won't. And if it goes in, then you know that this bottom slot will be matched up with the hole for the retaining screw on the bottom. So this one's a little easier. Now when you get to the auxiliary, that thing rotates all the way around. There's nothing else that can hold it. So the only thing you can do is make sure that you get that hole matched up. So let's go ahead and drop these chokes in. Make sure. Yeah. You can actually feel it when you're in there with your finger, that it only turns so far, right? It goes in there. And that should slide right in with no resistance. Again, get it matched up. Gotta get it past that pump jet. Oops, my finger got stuck. There we go. You can see it. Once you get that pump jet in there, it doesn't move. It won't spin around once it's inside in the right spot. All right, so I'm gonna change the camera around so you can see how we line up this auxiliary jet. All right, so with everything assembled, let's see how it idles. That is how that is done. I suppose I could pick it up just a little bit. I can't just let it idle. I got to give it a revving. Because you got it, right? Well, that is it. That's rebuilding the carburetor, rejetting the Weber DCOE 45. In my next project, we're going to build a cool air supply system. It's going to come in from this portal right here, and we're going to build like an air box right in here. Somewhere about here we're going to put a filter so we can have good, clean, filtered air, but the source of air is going to be from the front instead of in the engine bay. So we'll get some cooler air, give us a little bit more horsepower. So anyway, there you go. That's rejetting of the DCOE 45. Any questions or comments, please make sure that you throw them in the comment section. I really like the dialogue and everybody else who can benefit from sharing the knowledge. So that's all I have for you this week. Check back later and we'll continue the project.